Hi, welcome to this Open Security Summit session in November 2021. And we have Matt, which is going to give us a really, and I see a couple of little things on the presentation, very interesting view. And well, actually, I think it's a very super important topic, right? On security, which is the importance of blast radius, which is actually interesting connecting to a couple of other sessions we had on the summit where we talked about putting context into the risks, and then actually, doing threat mapping where you use worldly maps with threat models, right? So this should be very interesting. Matt, over to you.
Thank you very much. And we were just chatting, obviously, before the start of the recording, and it's kind of a shame we didn't record that bit because I feel super excited about this presentation. So thanks for having me. 2 minutes in, and I've already been given some suggestions on how we could kind of do cool things and improve what we're doing here. But yeah, this presentation is really about me sharing some of the work we've been doing and some of the way we've been thinking about security at Bridgecrew, which is where I am a developer advocate, and kind of showing some of the work we've published and kind of how we're thinking about blast radius, very much from like a infrastructure as code security perspective. So that's kind of the angle we'll come into on this. And it's kind of heavily Helm and Kubernetes based because that was the kind of area and data sets that I wanted to kind of dig into and research a little bit more while we were producing this work. But hopefully that sounds interesting to people. And yeah, hi everyone. I am a developer advocate at Bridgecrew. Bridgecrew does codified infrastructure as code security. So if you're looking to make sure that your runtime and your Terraform and your CloudFormation and all that good stuff is, as secure as it can be, and we'll kind of dive into what that means. We have open source tools and platform to help with that. I have been involved with containers since containers weren't called containers, when it was still just kernel components and Solaris had branded zones that you could run a Linux user space on. And I like breaking things more than fixing things, I guess, because I've been a hobbyist pen tester for as long as I can remember. In other kind of post-COVID news, I am in person at reInvent this year. So if any of you are also going to reInvent and fancy catching up and having a beer, please do reach out to me. It'd be great to kind of meet some of the wider kind of DevSecOps and security community. I also promise that is not COVID. I had a PCR test yesterday, but I do have a tickly cough, so I apologize in advance. So I want to start, and I'm hoping to kind of not do that thing where I'm just talking to developers. There's obviously multiple personas when it comes to all things security, but I want to start by deep diving into the day in the life of an application on a Kubernetes cluster, just to kind of set the context of what we were trying to drill down into in terms of our research. And for that, we kind of have to initially take on the persona for this talk as of a developer. But I'll hopefully provide some kind of more team leadership and kind of other suggestions afterwards. But for now, let's put our developer persona hat on and look at the day in the life of an application. So I was joking when I said, that sounds like there should be a children's illustrated version of that book, until someone previously pointed out to me there already is a illustrated children's guide to Kubernetes. So if you have children and want to confuse the crap out of them with basic Kubernetes principles, that might be some good nighttime reading for you guys. So yeah, the story of an application on a Kubernetes cluster. If we have something we need to run, a new component, a new microservice, a database to support something or other that we've already got running or is already in development, something new that isn't currently running in our environment, and our environment in this case is Kubernetes, are we going to go and work out how to package that application and write it ourselves? Let's say it's a dependency. Let's say it's something that we didn't write. It's just a common thing that gets deployed, like Nginx, or like a simple database service, or something that exposes S3 buckets up, whatever it is. Or are we going to write that deployment ourselves from scratch and work out how to package and test and build? And no, we're probably not. We're probably going to see if a solution already exists. Has someone already taken the work to package that for us? So we're probably going to, type what we're looking for with the word Kubernetes or the word Helm into Google or DuckDuckGo, or pick your favorite search engine. Not biased. Same with cloud providers. I don't like saying, oh, and we do this in AWS or Google, or just, yeah. Whenever I say one, I mean all of them. Please don't think I'm biased. And, are we going to do that? Yes, we're not going to write it ourselves, like every other part of development, where if there is an existing module, we're going to use it as a dependency rather than writing millions of lines of code we don't need. And we find the same is 100% true in infrastructure as code. And so if we did type in a word with Helm or Kubernetes, we would probably end up at Artifact Hub. For those that don't know, Artifact Hub is basically a CNCF sandbox project designed to help people kind of list and publish anything to do with Kubernetes. So operators, Helmcharts, kubectl plugins, you name it. So you'll probably find yourself here, and you'll probably find a Helm chart that does what you need it to do. And so you have some options there. You can either download and run it, hopefully not in your production environment to start with, but you can download and run it and see if it does what you were trying to do, so that you can put a tick in that box and go on and actually deploy your application, because your job isn't enjoying running Kubernetes. Your job is deploying code for your business or your business or your customers or whatever it is. So you're going to try and get this done as quickly as possible. You're going to download and run this thing. And realistically, that's what you're going to do. That's what we all do. That's what we do when we need to install an NPM package or a Python package. We're going to reuse the code that's already there. And so we took all of the, in a previous set of blog posts that you might have seen from back in May, we took all of the back then publicly available Helm charts from Artifact Hub. So there were thousands of them. And so we automated downloading each one, scanning it with our open source infrastructure as code tool called Checkoff. So we templated the Helm chart out using its defaults, created the resultant Kubernetes manifests, and then scanned those Kubernetes manifests for common security misconfigurations against the CIS Kubernetes 1.6 benchmarks. You could do the same today against the newly released NSA suggested Kubernetes security benchmarks, but very, very similar in what they're saying. Don't give root permissions to your pods. Don't map secrets in there if you don't need secrets in there. All that good stuff. And so we went and we did a 3-part series of blogs looking at this data we generated. And what we found is you are more likely to download an insecure Helm chart than you are finding a secured Helm chart, or one that kind of doesn't have any issues against the CIS benchmarks. And if we kind of drill down into that original data, even if it wasn't, specific things like root containers, although there was a lot of that. So there was a load that allowed privilege escalation. There was a load that didn't kind of drop net raw capabilities. There were a load of root containers, but also things that I still think need to be considered in a security perspective, like CPU limits and memory limits, because these are the only things that will allow the Kubernetes scheduler to protect itself should you have a runaway application chomping memory or, chomping CPU. Without those limits set, that one application can very easily take down your cluster, or at least take down a node and cause some availability issues. So yeah, lots and lots of kind of insecure defaults. And that's not to say we shouldn't be reusing infrastructure as code. Of course we should. We're a reuse industry effectively in IT. We always, that's the whole point of modular code. That's the whole point of, pip and NPM. It's just that just like we would never think about using, or shouldn't think about using, those dependencies in production without validating them, pinning them to a version, checking there's no CVEs, checking what libraries they're using, checking what other dependencies they have, all that good stuff that, we do as a secure practice. We should definitely be doing the same with our infrastructure as code, because it doesn't matter if our application code is secure, if our infrastructure as code is exposing the ability for an attacker to kind of get under our code into our infrastructure. And we found exactly the same a year ago when we first kind of thought about doing mass scanning of public infrastructure as code against the open Terraform registry. We did exactly the same. We took all the Terraform modules we could find, and we scanned through them again with Checkoff because it supports multiple frameworks. And yeah, we found very, very similar. You are very, very likely to get a misconfigured piece of infrastructure as code. And the reason for that is the same reason we have across the rest of security, right? It's the security versus usability debate. Like, if I am trying to help someone understand a Helm chart, if I want someone to use a Helm chart that I'm publishing so that other people can use it, like, which one is going to make most sense to a user? Let's take a user that may only just started having written Kubernetes stuff. Maybe their team's only just moved on to Kubernetes or Terraform, or pick your poison. Which one makes more sense to someone when it's templated out? Is it the one on the left, which technically deploys the same application as the one on the right, or is it the one on the right whose manifest doesn't even fit on the page? Obviously, the one on the left makes a hell of a lot more sense. You could explain it to someone what it does who doesn't even understand Kubernetes, whereas this is just insanity. And this is actually a snippet of taking this Kubernetes deployment and making it pass all the CIS guidelines. So if you're new, or even if you're not, how are you meant to know all of these things that you need to add to your manifest or to your Helm chart to make it past these guidelines? So having open source scanners like Checkoff, super useful for working out if you've got issues like this.
Matt, a question here.
Yeah.
Michael, right? Is basically saying, I wonder if your team at Palo Alto has seen a trend of how the threat actors are abusing these misconfigurations.
Yeah, 100%. And that's actually where we're going. So if I could hold that question a little bit later, if that's okay. Because cool. what we found, and so by the way, just as I've already kind of mentioned it a couple of times without giving any context, Checkoff is an open source IAC scanner, and that's what we've used to kind of generate all the data sets I've shown so far, and the data sets we'll have a look at in future. And it's designed, by the way, not to run manually. If you're interested in kind of getting this data for your own infrastructure as code and going, hey, like, am I running insecure infrastructure as code, either written in-house or downloaded from the internet? It's designed to dump in your CI pipeline, just like all your other code security and your other kind of code actions. So definitely not something you need to think about every day and run manually. It's literally just designed to be there to give you information on these infrastructure as code misconfigurations. And so once you do that, once you maybe run something like this in your pipeline, you'll face two problems. And the first problem you'll face is, like, when, I'm sure we've all been there, we've probably run a CVE scan against a container and gone, oh God, where do I start? Exactly the same with infrastructure as code misconfiguration. You can't have a manifest this big and turn it into a manifest this big without there probably being quite a lot of issues to solve. And you will get a crap load of errors out of most public Helm charts or Terraform modules that you scan with Checkoff. And where do you start with those? Which things are, oh my God, I cannot possibly think about pushing that even to a staging environment, that's really bad, versus, okay, well, that's not great, but that misconfiguration doesn't really apply in our case, and things like that. To answer the question that Michael posted, I've just seen the comment that he needs to drop. Yes, and there's actually a cloud threat report out by the Unit 42 security researchers, and we actually gave them and collaborated with them with some of this data that I'm going to show to kind of help them tie together, general internet use of misconfigured infrastructure as code with what they were seeing in the real world through like red team exercises and looking at kind of attacker trends online. So definitely good to check out, and definitely reach out to us if you have any more questions on that, because they are really good guys and are doing super cool stuff with modeling that security stuff.
So Matt, the main focus that you have here is on basically the security of those basically Helmcharts, right? Basically the thing that sets everything up. So here's a question for you. What have you seen that works or people use in terms of writing tests and integration tests for those Helmcharts?
Right. So I think that's the thing, isn't it? It's getting the unknown. It's getting to like known unknowns, because how do you know without a tool like Checkoff that you need all of this stuff in your Helm chart to create a kind of secure, passing the CIS benchmarks manifest? And even if you do know all this, what do you do when you have hundreds and hundreds of these errors for maybe every single Helm chart that you're currently using in production?
Yeah, but I'm thinking about something even a bit more simple, right? So if you go back to the previous slide, right?
Right.
If I do feel that, and I want to see, because you see a lot more Helm charts than we do, right? Can you go back to the previous slide?
Which
one that
one,
had I love the running Kubernetes. Okay, exactly. I love that name. It doesn't fit on the page, Kubernetes, right? That's such a lovely title. So if you think about it, like when I think of a test, right, a unit test, an integration test, right, it's almost validating an assumption, right? And also it should be used during test-driven development, but ultimately in the end you get almost something that validates X, right? So the interesting part here is that we should be writing a test on the left that still passes when you add the right. Because ultimately, right, if you think about it, what you're basically saying is the left has almost the core functionality, right? It has the replicas, it has the labels you're applying, it has the containers you're using, it has a bunch of stuff. So one of the areas I'm still want to find a way to do better, but also I want to see what best is out there, is that I think that we now have a good understanding for writing tests in codes, right? If you think about it, we understand about unit tests, integration tests, BDD tests, etc. But when you go back into the kind of infrastructure as code, I don't see the same level of maturity, right? I don't see,
100%.
It's always going back, 10 years where people say, I don't need to write tests because my code is declarative, right? It does what it's supposed to do, right? Read the code, right?
and this is the thing, right? It's declarative. It will do what you tell it to do. The problem is there are so many knobs and switches on every single piece of cloud provider infrastructure that by default, you're not gonna, yes, you will get something, but it might not be a secure something. And I think what you're talking about, like, so the idea with Checkoff is you wouldn't have to write those tests. Like Checkoff will alert you. We don't care about whether technically it would work, whether it would be Kubernetes-ish. We care about, does that Kubernetes manifest pass the CIS security benchmarks for Kubernetes, for example? And so you would use this, and we have the built-in tests in the Checkoff open source tool to answer that question. However, and this was the thing that I think is where the industry needs to go when we're thinking about this, and this is, I think, how, to your point, we mature. When you will then just get 100 failed results, like, we need to consider, okay, well, what is it that actually matters? Okay, I have 100 things that don't pass the CIS benchmarks for Kubernetes. Which ones are really going to put my application or my company or my infrastructure at risk? And so we started thinking about that, and we started thinking about how, to your point, right, we're really good. We've got a lot of history with application code and security testing it, and writing tests that consider the security and checking for CVEs, independencies, and things like that. So, when we hear CVE, when we think about CVE, it's familiar. We know we need to do something about CVEs. We know we need to patch our application. Infrastructure misconfigurations, they're not CVEs, but they don't have the same scariness to them, and they should, but they don't. And so we started thinking about like this idea of, we really need to start thinking about CVEs and misconfigurations together, because they are kind of, as you say, infrastructure here in misconfigurations, CVEs sat on top. Like, do they interact with each other? So case in point, this would technically be against CIS guidelines for pick a cloud provider. We have a security group with ingress open to the world. That's going to flag up. You'd need as a team to go, yeah, this is an exception. It's a public website. It's a public front end. It's meant to be open to the world. Why isn't it behind a WAF, or but whatever? But technically, this would flag up on any kind of infrastructure as code, security scanners. Probably a bad idea. Are you sure this is meant to be open to the world? So is it misconfigured? Yes. Is it actually risking anything in your infrastructure if there's no backend service attached to it? Well, no. Unless there's a possibility that someone has a 0-day for, I don't know, Amazon's built-in load balancer, probably not. Because all it's going to do is drop that traffic on the floor. It's not going to access any backend service because there's no backend service bound to it. So this got us thinking about, other scenarios where CVEs and infrastructure misconfigurations, to Michael's point earlier, it's, couldn't have been a better question for this talk, go hand in hand. Because if we think about attack chains and how people get into infrastructure, we often find that a CV, if it starts with a misconfiguration, that's the kind of first foothold, and then maybe a CVE is used to increase that foothold and move laterally. So like in this scenario, we have an open load balancer security group that is bound to something, and it shouldn't be public to the world, but it's been misconfigured. So it's exposing a monitoring endpoint. And because that monitoring endpoint is meant to be internal, it might not have authentication. It might be not patched for some recent CVEs because it's just internal and it's not meant to be publicly accessible. And so through an attacker finding that open security group, which exposes this internal monitoring endpoint, they use a CVE to get container access. So they've had a mixture of misconfigurations allowing exploitation of an otherwise probably non-exploitable CVE. And then once they're in that container, they had a shell in that environment, potentially another misconfiguration with leaving default Kubernetes service accounts exposed into that pod allows a lateral move to the Kubernetes API and, potentially to access or look at or fingerprint some of the rest of the infrastructure running in that Kubernetes environment. That's before we've even thought about, well, maybe there's another CVE once they've got a shell that lets them drop onto the host and kind of all that nasty stuff. But you see how they very much relate to each other. And equally from the other side of things, let's say it is meant to be public. Let's say there is meant to be a public interface for an API or one of your web pages. And there is a CVE in that container or in your application, which again allows container access directly via a CVE from a public app. But a misconfigured default service account, which is an infrastructure misconfiguration, is still going to mean the attacker finds it easier to get from that containerized pod into the rest of the infrastructure. Or potentially a misconfigured network policy, not on an external load balancer, but within Kubernetes, allows them to use that shell in that first container to then go and find other maybe internal infrastructure and go around that loop again, gaining more and more access. So we got kind of interested with this and started thinking, okay, how do we visualize this? Like, because there is so much context there, isn't there? You need to understand infrastructure as code. You need to understand infrastructure as code security. You need to understand containers and dependencies and CVE scanning. Like, how do you visualize whether or not there's an attack chain for any given piece of infrastructure? And Helm charts for us were a really cool, because Helm charts themselves are both the infrastructure as code, like I am deploying this Kubernetes manifest, and the language of the infrastructure as code is Kubernetes in this case. But the Helm charts, because they're designed to deploy an application of some kind, also embed the container image names and versions, which themselves have the application. So within a single Helm chart, you actually have information about potential CVEs and the Kubernetes manifest for misconfiguration. So we thought, okay, let's take those together and start considering the CVEs and misconfigurations together for a given Helm chart rather than kind of seeing them as two separate entities. So we started trying to visualize blast radius and quickly realized that we needed a graph after spending a lot of time with CSVs in AWS QuickSight, realizing that none of the bar charts would give me a visualization of the information I was trying to get to. So we turned to a Python graphing library, NetworkX. And so we did exactly the same as we did with the original data set from March, with taking every single Helm chart from Artifact Hub, downloading it, parsing out the default template Kubernetes, scanning that Kubernetes manifest for misconfigurations with Checkoff, but then also for each deployment type or each, anything with a container image in it, basically find that resource, save the name of that resource, look at the container images and versions within that, and then also scan those for CVEs with Twistlock, which obviously we have access through Palo Alto. So we use Twistlock to scan those and put that data together because it's all within that one Helm chart. So what we ended up with is this very hacky code base called Helmscanner. And I'm saying that fully knowing I wrote it, and it's very hacky. And what it does is it spits out these graphs, which we thought were kind of the easiest way to, at a glance, look at CVEs and misconfigurations for a given Helm chart together. So for each Helm chart in Artifact Hub, and we've put these all online, by the way. So for each artifact in Artifact Hub that's a Helm chart, let me find it. Here we go. So Bridgecrew GitHub.io /Helmscanner. And what we've basically done is a bit of a website, and you can search for every Helm chart up here. So I'm going to go and find one for, I don't know, someone name me a Helm chart.
Prometheus.
There we go. So we'll find a load of Prometheus stuff. And so for each Helm chart, you can also search via CVE, or you can search via an individual Checkoff rule if you care about that. So if we say, oh, he says that's not working. There we go. But for each of these, what you will be able to do is view the blast radius graph for each of these Helm charts and kind of zoom in and have a look at that. So what we can see here is we have the blue node is the root. We can see that within this deployment, we have a deployment object and a daemon set object. They themselves have some misconfigurations from the infrastructure side. And then that deployment and that daemon set themselves have a couple of containers that are being pulled from the key registry. So Prometheus Alert Managers 0210, and that itself has a bunch of CVEs. And then if you hover over these, you can get information. So we can see we've got a cross-site scripting issue with Go. You can see we've got, other issues with Go. We've got an encoding XML issue. So at a glance, you can kind of look at this and go, is that something I want to run in my infrastructure? Is that something I am happy running? And you can, by looking at what the infrastructure issues are and what the CVEs are, you can start building up a better picture of whether there is actually, hopefully this is useful in all the information's there to very quickly ascertain whether you think there is a valid attack chain, and you can use this to, at a glance, kind of prioritize, maybe you're using 50 Helm charts. Which ones are you already using in production that you maybe need to focus on patching and protecting the most? So hopefully this is useful. And that's kind of why we built.
No, this is very cool. Yeah, I can leave it there, right? So yeah, because the thing about this is when you get to this level, you have to visualize it initially in a graph, then in a map, right? Because see, the interesting thing about here is your x, in fact, your y also doesn't say anything.
If I could get rid of them in the bokeh renderer, I would, because you're quite right. At the moment, they mean absolutely nothing.
So the thing, so you should actually take a look at some of the stuff we've been doing with visualizing data in Jira. So how are you storing the data? What's your data store for this?
So this is all generated. As I said, the Helmscanner is open source. So we're doing it in two ways. All the data we generate is per Helmchart. As you can imagine, we generate a set of CSVs with the raw output data for each Helm chart, so that we can say, hey, like, this is the data that we built these graphs out of. So for each there is a CVE CSV, and there is a Checkoff CSV for each.
CSV, you mean, comma limited
comma
file,
separated file. Yeah. So if you
wanted
wanted
to columns, what's the data? The columns are just like so it's a simple table, right?
It's a simple table, yeah. And we just have a set of, we have the same set of columns for every single Helm chart, and we just produce two files for every Helm chart. So if you wanted to, so for example, the Unit 42 guys, when they took this data to work with us on their report, they actually imported all that data into SQL, so they could start writing kind of complex queries across it and joins and things, and that was their preferred way. To generate the kind of basic stats and graphs I showed you at the beginning, currently put that into AWS QuickSight, so that works really well because we store all of this data in S3 once the scanners found it. And then what we're doing while we're also generating the CSVs is we're creating a network X graph for each chart. And then there's some code there that at the end of scanning the chart, and we have all the data in this network X graphs, which is where we get all of our edges from. We are loading that into the bokeh open source library, which itself can take a network X graph, and we add some colors for each of the nodes and things, and we overload all the description information for the hoverovers. And then what bokeh actually ends up dumping us out is a self-contained HTML and JavaScript page, which just gives us this. And then all we're basically doing is adding some Hugo templating to the top of that, so that we end up with a usable, browsable web page.
So
pretty
Hugo
hacky.
Go Hugo, right? So just a couple of ideas for you guys to play with, right? I think, and actually check out the presentation where the guy talks about threat mapping, and actually there's another one with open source where he talks about storing a lot of threat modeling data in YAML. I think for some of the stuff here, you find that YAML is a bit better rich, because you can create almost like, again, domain models that already have a lot of massage data. The trick that I think you need to get into is the idea that you need to create intermediate graphical representations for your view, right? So the thing about this, right, is that you need to have a way to store, data in a kind of a native, kind of graph format, which I like. Jason, ironically, we use Jira a lot for this because Jira nodes are really good, right? Because the Jira nodes have they are very rich. Because if you think about it, each of these dots is a node, right? Yep. And you want to think of them as the nodes. You want to see the relationships amongst them, right? So you kind of want to, so one of the things we do is we actually store the data in Jira, but we actually pump it all to Elastic, and then we query Elastic, because Elastic is a much better database, right, to query, right? And the other thing I would look at is actually using some other web technologies to visualize this, things like Viz.js and a couple of others.
So this is obviously V1 of our Helmscanner. I am very aware, and I do not like front-end languages. That's just me personally. I am very aware that the tooling for graphing and visualization is better in the JS community than kind of Network X and Bokeh. So we know that our next version is going to have to go that way. But we also have some other kind of cool ideas for adding to this data. kind of, surfacing maybe criticality of on a slider, so that you can say, hey, I only care about critical infrastructure things, and I only care about CVSS scores above, 8, just to kind of turn the really, really messy graphs like this one into something a bit more usable.
Yeah. And the other thing that is interesting is, I still don't have sometimes a good term on this, but you don't have to be limited by your graph structure for the graphs you create, right? So I'll give you an interesting example, right? If you look at the previous graph you showed, am I correct to say there's a number of times where you have the same CVE linked to multiple things, right?
Yes.
And the problem with that is, although that technically is correct, when you visualize it, it's not easy to see what's going on, right? So sometimes what you want is to, because you end with this. Look, for me, every time I see this, this is not bad, right? But this is reality, right? What you have there is reality, because you end up with, every graph that is more granular ends up with something, well, either like this, or you end up with a massive blob where lots of things are connected to each other. Right. And the way sometimes to deal with that is you can create, GraphQL, the concept of GraphQL, where GraphQL is really interesting because GraphQL creates views, right, to the front end. Some of the front end say, hey, give me data in this structure, and then they design it so that's super easy to create visualizations. And I think this is the way you want to handle here. You want to say, I want to show X, and then what you do is you create multiple graphs, right, out of it.
Yeah.
Right. And each graph, basically, usually is the first graph gives you the universe, right? This is everything I care. And then you start to create subgraphs out of that initial graph that now tell the story and basically shows you that level of granularity that you want. But this is really cool, right? But it's the only way to visualize it. And then go on.
100%. Yeah. Like I would like these to be less messy, but I think the fact that they are messy kind of highlights the problem we have at the moment as an industry, kind of, because these are all I kind of also want to maybe add like number of times downloaded as a data point into these graphs as well, just because there are not many that don't have a bunch of CVEs in them, and will those CVEs all be exploitable? No, probably not. If you've got like something that needs, it's only kind of local access for a CVE. So the CVSS scores are important. And like you said, there might be better ways of creating better views, which kind of show like something a little more yes or no. I guess people still require context, right? To go and look into these graphs. Like I could not take someone that isn't a security person and go, hey, look at this graph. Tell me if it's okay or not. Like, should we carry on deploying this, or does it need urgent attention? You'd
but the
still
security
need someone
person
to
also
dig
doesn't
into
know
it.
that, right? Like the irony here, right? And is that for this to become useful, you need to add lots and lots and lots more data, right? Because your context will come from that data. And that's why, really get into worldly maps, because what the worldly maps would also give you, right, is a great set of context between a chain, this goes there, goes there, goes there, but also the maturity of it. And the maturity could almost be like, for example, exposed to the outside world, right? So you can basically say that, you can almost go from left to right. It could also be, that, on the left, it's not exposed to the outside world, and on the right is exposed with no authentication, right? Yeah. So suddenly you have context, because the thing about this is that, even as our security experts, right, we don't, this doesn't tell us a lot, right? This just tells us there's a lot of stuff in here, but this could be very low risk if every one of those CVEs, are not, don't have a big blast radius, right? So the irony here,
you could be in this scenario, right? Where
exactly,
it's like,
right?
Yeah. So interesting you mentioned that, actually, because the more we've been thinking about this, like, obviously this is a point in time capture of a public Helm chart, right? That we've templated out to show that in its default configuration, this Helm chart is not secure. And it's not just insecure from an infrastructure perspective, but it's also not insecure from this blast radius, which has all these CVEs hiding, waiting to potentially bite you in the ass. To your point about needing to add data, obviously the only way we're going to want to do that is like, we're not going to manually go through 6,500 Helm charts and plot each node on a Wordley style map. So we'd need a way of automating those axes, as you say, like, and is it exposed to the internet is a perfect example.
Yep.
However, to do that, we need to actually take this data from runtime. And this is what we're finding. Like, we're finding this, by the way, not just on this bit of research that I'm presenting today, but in general with what Bridgecrew does and how our product protects customers and all that good stuff is, yes, we can provide you misconfiguration information. So we've got a VS Code plugin that as you're typing Terraform will go, hey, you're about to forget to do this, or you're about to make that bucket public, or, you know, all of those checkoff policies. Yes, we can give that information to the developer while they're writing it. And that's the quickest, easiest place to fix something, right? Because it's not been committed. You don't have to revert a commit and all that kind of stuff. But as we move through CI/CD and into production, there's more information available as to the context of what the user's actually doing with that chart or that Terraform that we just don't have back when it's just sat in a developer's IDE. So I think everyone that just does point in time security scans of either the images or while they're still in the image repository, or point in time scans of Helm charts, like we're kind of doing here, it's not enough. Like, you need to follow the life cycle of that piece of infrastructure as code all the way through into production,
and all the way back.
And all the way back, right? Because only then do you have context of, as you say, whether it's really dangerous. Yes, there's a million CVEs in an EC2 VM, which is switched off, don't really matter. Right, exactly.
But okay, but here's the question. Have you thought about the schema of that analysis? So let me replay back. So when the way I'm picturing what you're saying, and I think is pretty spectacular, right, is that you create a graph, right? So you create a graph of, it's almost like you create 5 graphs, right? You create a graph in the IDE, look exactly here, right? There you go. You create an IDE graph, a pre-commit, a PR graph, a CI pipeline, and a runtime production. First of all, the diff of those graphs is super powerful, right? So I guess the first question is, do you have a schema that you can save that graph as code to be added to a GitHub repo?
Yes, at the moment we do. It'd be the NetworkX object, which has an export format.
But that doesn't sound very consumable.
No, but it could be consumable by another piece of code that is automatically doing that diff.
Yeah, but that has to be readable. See, that's the thing, right? That's why I feel that. See, I've done this before, right? Like I've gone to the NetworkX world, and just to be, I know I like some of the visualizations. This is the NetworkX Python library.
Yeah, right? So you're talking more like Cyclone DX, like a software bill of materials, right? Like it's a YAML file. Think of YAML or JSON file, right?
Yeah.
Like, so with a known kind of almost standardized, this is a security report in this graph format for these components with these issues, and
Well, kind of. I'm thinking more of there's some of it, but there's also the relationship. There's also the information of what that is, right? Because the thing about a graph, right, is that you have the graph, which is the raw data, but then you have another graph, which is what you care about it, right? And that almost, becomes human consumable, right? Because you start to say, like for example, like that situation where you have a machine connected to a bunch of CVEs, but then connected to nothing. Actually, and this is the irony, like, you can basically, what we're looking here is a threat model, right? Or a diagram for a threat model. Because if you look at a threat model, what you're mapping is the inputs and the outputs and relationships in the data, right? And the thing that the threat model, I think most of threat modeling products struggle is they don't have a lot of real world data. They almost rely on people telling you stuff, right? Where what I think is very valuable here, and now I today have 2 hats, right? Engineering and security. And I would say, I think you get this right. And I think this is critical, right? You're going to get a lot of value just on engineering, right? And almost like security should be a side effect, because good engineering doesn't have security side effects, right? But most engineer, most, even, and you'll see this, most Helm charts that you have there, you can already see that the people who wrote them don't fully understand Kubernetes, right? They don't understand the best practices. Almost these CVEs are almost a pollution, a side effect of a lot of teams not fully understanding, how Kubernetes works, right? So they overcreate things, they underdo stuff, or they have complexity on it that is almost sometimes created by not understanding how Kubernetes works, right?
Yeah, 100%. And also just on that point, I'm loving this, by the way. I never get to usually when I present like this format of it being more like a chat of people that would do LobbyCon, this is so fun. I want all my talks to be like this in future. This is great. But it's not just CVEs, right? This is probably another, to your point, it's probably another data point for the graph, because it doesn't matter whether there's a CVE or not. If there's a misconfiguration in the infrastructure as code, which allows an attacker to get into a pod, and that pod has curl and NSEnter and SUE, and I don't really need a CVE to do damage in that infrastructure or to fingerprint other services and things like that. And we see so many, as you say, we see so many containers just built to the point where the engineer goes, it works, great, ship it, that have all of these tools in.
Yeah, but I think, look, CVEs, you have to be careful, right? Because CVEs can be a red herring, right? On this, right? I think CVEs are a good data set, but I think you need to start thinking about a rules database, a rules engine, a rules language, because it is that. So it's almost like when you talk about blast radius, in my head, I have an attack tree, right? This leads to that, leads to this, leads to that. Well, that's a graph, right? That's a graph, and eventually you can make it a map. So, by the way, one of the things that Simon Worley talks a lot about maps, and it's quite interesting, is a map has a bunch of properties that a graph doesn't, right? A map has context, position matters, right? It has a direction, allows movement, right? Allows an evolution, allows gameplay, right? And that's the thing that I found very interesting here, which is, I really like this idea of visualizing the status of my Helm charts, right? Visualizing in almost like you almost can look from a distance and you can already say which one you should be worried about, which ones you shouldn't be worried about, because you see the complexity, right? You see the messiness, right? That is in there.
Yeah, more dots equal bad.
Yeah, and because the bottom line, right, is that the more connections you have in these environments means more moving parts, right? Less isolation, more single points of failure. Like a good example is if you map which node in Kubernetes can talk to what node, or which pod can talk to what pod, your graph will explode, right? Because it becomes a gigantic blob. And that's why I was saying that sometimes you need to you need to think about, it's not because this node is connected to that node that I'm going to visualize it like that, because the graph also has to tell a story, right? It has to be consumable, because you have to be able to look at the graph and going, okay, how am I interpreting this? So on the right is bad, on the top is bad, on the bottom is good, right? And then you see that evolution on this. And you want a mode, just to your slide here, where you keep adding more and more and more data, right? The beauty of a graph is that you can scale quite spectacularly, right? You can have parts of the graph that are enormous, but maybe you just extract some parts of it.
You collapse them when you don't need to see them, but the data is still there in terms of its connections, and the context is there, even if the summary graph is only visualizing certain parts of it.
Yeah, absolutely. No, but really cool, man. I played around in the past to try to build like a serverless graph engine, right? Maybe we should, show you some of that stuff. Right?
So I've already had some requests from a couple of companies like doing stuff in the infrastructure as code world that said they would absolutely love like an API to query this instead of just the HTML and CSV outputs. So would love to talk offline about that with you, because I think that's the next step.
You need to make this serverless, right? It needs to be consumable, right? I think actually, if you look at the way we create logs. In fact, another session I was talking about how we create logs, right, on the summit, is that the approach that I always take is that you take the data and then you create multiple representations of almost JSON, if you think about, or YAML, of the same data. Each one is simpler, it's simpler and simpler, all the way to Elasticsearch or multiple versions of Elasticsearch until you hit something that is very easy to visualize and very easy to graph. And I think that's the approach that you want to take here, right? You want to basically allow the power user to be driving it, but you leave behind these artifacts and is that CI pipeline, that ability that you have to keep modifying the analysis, that becomes the most important thing.
Yeah. I'm doing that thing now where I'm trying to engineer in my head as we're talking. I'm like, how would a change in Kubernetes update this dynamically? And yeah, it would definitely need to be like an online, like you said, like persisted graph to handle that.
Yeah, so you need to think about how you store your graph, right? The data that you store your graph. I have to say, I really like YAML, right? Or other things to store data, because that's a one-off. You can load them up, right? But YAML is already a graph, right? It's a hyperlinked set of data, right? Which you can process very quickly, right? And you can load. Again, I forgot to mention, what I like about NetworkX is its ability to analyze graphs, right? NetworkX has a very good algorithms to for example find shortest path,
right? Because it's meant more for data science than visualization. Yeah.
But when I looked at it, it was horrible to maintain the data, to massage it, even from loading a lot of stuff into it, because it forces you to have the full object there, right?
Yeah.
So for example, I found that actually pumping it to something like Elastic sometimes even better, because although Elastic is not supposed to be like that, actually it's basically indexes everything and everything. So almost Elastic already gives you a graph that you can query. Because if you think about it, Elastic, if you give a JSON to Elastic will index every field against every field.
But how are you maintaining connections then when you're querying your Elastic data?
Yeah, so what's really important, and you can see this very well the way we've done our Jira, right? What's really important is that your schema is the relationships between the nodes, right? And the thing that is very important that I don't think you have probably explored a lot is it seems to me that you only have one type of relationship or not a lot of relationships between the nodes, right? Where you really want to recreate reality, right? It's kind of like, if you think about it, it's to say, for example, this Kubernetes cluster, which is a node type, has a bunch of namespaces, which are another nodes. And the namespaces were created by these Helmcharts. And then the namespaces create these pods. So the pod is parent of this, who has the nodes, who has the ports, who use that secret. So what you're doing is you're creating a schema that represents Kubernetes relationships. And then when you query the graph, you walk the schema. So you can basically say, show me, if I start on a node, so I should be able, for example, to start on the port and hit the charts. I should be able to start on the node and hit that. But the problem you have with this is that if you don't create a good schema, you cannot go more than 2 nodes in before your graph explodes.
Right. Yeah. Because you need to know what to hide and what not to hide based on what and this all kind of reinforces the fact that this needs to come from runtime, because otherwise you don't have that rich data.
I disagree with that. I don't think
I can't possibly know whether something's exposed to the internet unless I know right now that pod is bound to a service or XYZ.
But Kubernetes, but hold on, the Helmcharts give you all of that.
They sure, but
I don't need a live Kubernetes server to make those connections, right?
As long as it's defined in the Helmchart. But at the same time,
in fact, I would argue this is what I think is really interesting here is to think about the diff, right? So, for example, in some of our deployments, my expectation is that we have immutable clusters. Mm-hmm. So we have a view that our cattle is actually the cluster, not the pods.
Yep.
So instead of having 5 clusters, 2 clusters, whatever that you
have thousands of, and I started seeing that more and more actually, because then you don't end up with tainted secrets and things left behind.
Exactly. And, So to be fair, we support both on a CI pipeline. But so I would actually say that in some of our deployments, my expectation is there's no difference, 0, right? Between
your Helm and your
production and the Helm charts that build that. Because apart from the data itself, nothing else should change, right? Okay, you might have more running pods, But
Yeah.
from a configuration point of view,
We all know that a lot of companies don't have that luxury though.
oh, absolutely. Right? And to be honest, right, I actually think from a security point of view, it's a good example of those signals that should trigger an incident straight away. So I actually think that
that because we're already doing drift detection at Bridgecrew, so we can alert on Slack as soon as we say, hey, we know that this piece of Terraform or this piece of Kubernetes created that real runtime object. That runtime object now doesn't look like that manifest. Something bad has happened.
Exactly, right.
So,
but that's now your graph, right? Your relationship, and I think your deltas between them. So I think when you say you want live from live clusters, I'm actually thinking that what you want is a snapshot.
The snapshot of the Helmchart, a snapshot of the live cluster, and the diff of the graphs. Like you said earlier, like diffing that graph.
Yeah.
Whatever shows up as a difference is an interesting data point.
Yeah. So for example, like here's a cool trick for you, right? So we did this for AWS. So we have a Lambda function that goes to AWS and downloads the EC2 instance data, right? In fact, it downloads this data, the ports, the mappings, and creates a JSON file that gives you makes it really easy to see which ports are open, for example, right? Which is which stacks. The interesting thing is how you save the data. So the way we save the data is that we have one index. Do you know about Elastic and how keys work?
Yeah.
So Elastic
for my sins, I've maintained a couple of Elasticsearch databases in my time.
So on an index, you have an index that the key never changes. The key is the image ID. So that means that index is always the latest thing. You always gets but the key here is you only update if you change, right? Because this data doesn't change very often, right? So there's no need to keep writing it, only if it changes. And then
because you're not going to change the image ID every
but also the setup, right? So the memory is not going to change, or the state changes. So when the state changes, other things that you want to track. What's interesting is that when you capture that, and then we also log an entry every time the state changes. So again, the history doesn't have one entry per 5 seconds or 10 seconds or a second.
It's just on changes.
You have the delta. So imagine you can give me that for a cluster, right? Imagine you can give me that for a cluster where you show me even the cluster growing, right? And the cluster being deployed, etc. That is insanely useful. Like that's insanely useful for development. Forget about security, right? It's insanely useful to say, hey, we pushed a new version. Has the change been pushed? Where have the latest changes occurred in that environment? That
can we see? And you could start overlaying kind of more code base information in that as well. So if you took your unit tests, for example, or you took your integration tests and ran those as well as when you detect a change, and you can then see, as you say, from a software development perspective, you can see, well, I categorically know that change is in production, because not only can I see the infrastructure has changed and the image has changed, but actually I'm getting the right versions back in the integration tests, which are all passing. And very cool.
And that's why I'm saying that you need to arrive at intermediate representations that are human and machine readable, because I want to write the unit test or integration test on top of it. Right. I want to write a test on top of that JSON file.
You're not reading them. Sorry to interrupt. You're not reading them yourself because they're going to be massive, but you do want them in a schema that is consistent and parsable, like so that you can have your unit test, so that you can have your tests consume that JSON and go, yep. This is true. This is false. All good.
Yeah. But this is where, if I apply my engineering hat, I don't think they should be massive. They're only massive if you haven't refactored them, right? What you want to then look at is saying, what are common bits? And that's why you start to organize your JSON structure. That's the power of a graph. The power of a graph is that you don't need the data is assembled when you do the connections, right?
So hang on. So you're saying one JSON blob per node with connections to other, right? Okay.
Yes. Well, whatever makes sense. This the thing about this is that this schemas you evolve because you need to start with the questions, right? And then you need to if you don't make the evolution of the schema part of your design, right, it's never going to work, because there's no way you can design something that will do it.
Yeah, 100%.
Right? So that's why for me the key part here, even for the visualization, is that the point of the visualization is not necessarily to create something that is going to be amazing from day one, is to create something that allows to ask the next questions And eventually you're going to arrive at really clean, spectacular views, because there's a moment where you say, well, this is already quite useful, right? This already gives me exactly what I need. I don't need to do anything else, but you need that feedback loop, right? And that's why, ironically, something like Elastic and Kibana, they're not bad worlds to play with, because, for example, Kibana allows you to hyperlink everything and filter everything in one go, right? Which, and some of this is also about allowing you to discover what the data that you have. So you go, that's the bits that really make sense, right?
Yeah,
so
that makes sense.
Cool. Now
we need to chat about that Lambda-based graph database, don't we?
Yeah. No, to be fair, I actually think there's a tipping point. I'm seeing more and more graphs left, right, and center, right? But you want to start thinking about maps, because graphs, personally, you cannot have a map without a graph, but the maps is where the action is. The maps, and that's why if you take it, just read about Simon Worley, not initially, but what happens afterwards. For me, that was the big paradigm shift, because the guy talks about gameplay, he talks about inertia, talks about strategies that you do once, patterns that happens at graph level, right? It's almost like you have, and actually what you want to have is you want to have a map within the map within the map. That's where I was saying that each sometimes the dot or one map will become a dot in another one, right? Yeah. Because there's a reason why that guy is here, not there.
That you can dig down into, yeah.
Right. And that's why you want the context, right? And the context starts to say, well, I care about this and I don't care about that, right? So
yeah, that makes sense.
One more idea. So actually, you should really, spend a bit of time looking at the stuff we did with the risk, because it's very relevant here. Because one of the concepts we've done in risk is we introduced the concept of facts and the concept of modifiers. So they are the idea that you can have a lot of risks here, but if there's a particular fact that reduces the risk, then that modifies the blast radius going up.
Yeah.
Right?
Have you got some good reference reading there for maybe people on the on YouTube and things as well?
Some of the videos that a lot of the videos that we present at the summit are some of the best presentations. But but actually, if you just Google, me and graph databases, you'll find it, right? Because I've been talking about this for a while. It's just interesting because I found that the first place where I needed to solve this at scale was risk, because risk didn't scale at all, right? The way normal risk management is done. But I always felt that, for me, that was just the beginning, because, I want to actually make sure that my risk dashboard takes into account the Kubernetes cluster status, right? And they should, if you start to connect this data like this, right?
Yeah, 100%.
Good stuff.
Really good chatting. Yeah.
No, this is what the summit's all about, man. It's like, bouncing ideas, collaborating. What I think would be really cool, maybe for the next summit, is to maybe try to do a practical session or actually using, that tool, right? Because I think it would be, I really would like to see it in action, right? I think it's cool the way you show, but I think, like, for example, like the guy yesterday talked about a React component, right? A vulnerable React component, right? And how it's already painful to create, a Docker image that doesn't have a lot of freaking CVEs, right? Of React. Right. And I think it would be really cool to, again, connect those dots, right? And then see, look, can we create a Helmchart that is actually secured out of the box, right? Because, that's the key strategy that we're doing, right?
Yeah, it's good to complain on a CI pipeline. It's better to complain and offer solutions.
Oh yeah. Actually, you probably like this idea. So what we've done for our multi-cluster deployment, we have this deployment which we call 5 layers. Each one has different repos. The first layer, we call it bring your own cluster. So the first layer is that you define the Kubernetes cluster either as an AMI, OVA, managed cluster, etc. The layer 2 hardens it. So the layer 2 takes whatever that came and locks it down, right? Creates almost the most secure version that we can do, because you already have Helmcharts, right? But it's almost like one level at a time. Let's get a nice, clean, safe Kubernetes cluster. Then layer 3 applies the application Helmchart.
And then apply a nice, clean Helmchart, which is using nice, clean images. And
yes,
100%.
Yeah, and then layer 4, and this is an interesting thing. The point is layer 3 should be compatible with all deployments. So we're making this already compatible with what we call a single one node, one cluster, and multi-nodes per cluster, right? And running most of them. And then layer 4 is when you then make cloud-specific changes. So on layer 4, sometimes you modify some of the things that need to be generic to all of them. Let's say share storage. where shared storage needs to be, local when in one cluster, one node. But then when you run it yourself in a Kubernetes cluster, managed cluster, then you want to use, the local
Whatever
storage provider, S3, Azure Blob Storage, Google, etc., IBM, whatever, right? So, but one of the things I would love to be able to do is visualize even the blast radius and visualize the complexity of Kubernetes at each of these layers, right? Because, in a weird way, that also gives you confidence to say, yeah, when you make a change, we could say, well, if all you're doing is changing over here and you haven't changed the pattern, rock and roll, like ship it, right? Hey, if you change some of the patterns, I now want a threat model. I want security reviews, right? So
doing that diff is going to give those models a really easy visualization, and then you can give that to your security review team, and they can look at it and go, oh yeah, that's fine, because it's not connecting to anything here, or there's no extra nodes hanging off the bit that would matter. Yeah, 100%.
And so you can see that what you're now saying is that for each of the clusters, you almost need to have a business analysis that allows you visually, but also programmatically to query it, but visually that allows you to say, I care about this, I don't care about it. Like, I care about this latest change, or I don't care. Because that's the problem, right? Like, a lot of these vulnerabilities, they don't get created in day one, right? They get created ironically when there's a business feature, right? That gets, oh, can you make this happen?
Yeah. And can you make it happen quickly and now and yesterday? And 100%.
Well, look, Prometheus is a good example, right? Like when I was quite excited about Prometheus, and then when I start to see all the freaking things that Prometheus adds to a cluster, I'm going, right? But I didn't have a good way to visualize until we got deeper. If I could see, hey, actually, what are the advantages, right? And what's the thing, right? Then you can make it. I'm not saying it's not a bad thing, but you want to make good informed decisions, right? On this.
Yeah. Good ideas for version 3 for sure.
Good stuff, man. All right.
Gonna have to put my Node.js hat on.
Cool. All right, let me stop the recording. And now this is